Hello, everybody. Welcome back. I am going to continue with solving the quadratic equations. I left off with method 2, so now I'm moving on to method 3, and that is completing the square. Okay, by the way, completing the square is one of those techniques that should have been taught in Algebra 1, but I don't think any of you learned this, okay? So I'm going to introduce you to completing the square, but most of you will probably get this when you get to college algebra. You probably won't get it at this level. Or if you're doing pre-calculus at the high school, you might get it at the pre-calculus level. So this is just an introduction. If you don't get it, it's okay. All right, this is just another method to solve the quadratics. And if you cannot get this one, you can also use the quadratic formula. But guys, this is a very efficient method. And for my students, what I like telling them is that it works best because students hate working with fractions, apparently, when A is equal to 1. That's the leading coefficient. Remember, I mentioned that earlier. And the B value is even. So if your B value is even, A is equal to 1, perfect candidates for completing the square. So here's a quick example. X squared minus 6x plus 3 equals to 0. This is the ideal candidate for completing the square. X squared has a leading coefficient of 1. The B value is -6. Ideal candidate for completing the square. So I'm going to try and squeeze as many steps on here as I can, and then I'll move on to the next screen, okay? Step number 1. You want to move the constant term, move the C value to the right. So if I were to go to this problem right here and use a different color, I would take that +3, move it over to the right, so it becomes a -3. Now, step number 2, by the way, step number 2 and 1 and 2, you can do them in reverse order. It really doesn't matter. So you want to divide both sides by the leading coefficient. In this case, the A value. But guys, for this problem, if you divide the A value is 1, if you divide everything by 1, you still have the same problems. It really doesn't matter, okay? So we're going to bypass number 2. Number 3 is the critical step, okay? So this is where you actually complete the square. So you take half of B. And let me shorten this, okay? All right, there we go. Half of B. The B value here is 6, the -6, so you do half of it. Square it. And then you're going to add it to both sides. Add to both sides. All right, so let me go through the process with you. So the B value is -6. So we're going to do half of -6. That's -3. Then we're going to take that -3, we're going to square it. So we get 9. So now we're going to take the 9 and add it to both sides. Add it to both sides, okay? So guys, this will allow us to complete the square. Now, what just happened, okay? This is what just happened. On the left side, we just created a perfect square trinomial. And so this perfect square trinomial here, guys, you're eventually going to have to factor it. And you know what happens when you factor a perfect square trinomial. So let me go ahead and erase some of these steps here so I can continue. Hold on a second. And there we go. So -3 plus 9, that's 6. Oh, wait a minute. This is not writing. Okay, there we go. That's 6. Now, the next step, step 4, you're going to factor the left side. Factor the left side. Okay, so I'm going to do it the long way, so pay attention. For the left side, guys, you factor x squared into x times x. Then you got to find two numbers that multiply to give you 9 and add to give you a -6. 2 factors of 9 whose sum is -6. That would be a -3 and -3. See what I was talking about? You have a repeated factor. And when you rewrite these repeated factors, you rewrite it as a binomial square. And then, so the final step is to go ahead and solve using the square root property. I know what some of you are saying. I'm lost, Miss Althea. What the heck are you doing? I told you guys, listen, it's okay if you don't get it fully. There are other ways of solving these type of problems. Don't forget, when you take the square root of both sides, what do you always end up with? A compound solution. But we're not quite done. Why? The goal is to solve for x. To isolate x, we need to get x by itself. So you got to take that -3, move it over to the right. So now you can isolate x. So x will become +3 plus or minus the square root of 6. That's your answer. No, it did not come out to be 2 exact values, and that's okay. That's okay. I know, yeah. Okay, give me another example. I didn't get that. Give me another example. Okay, so here comes another example, guys. Let me see here. 26. All right. Let me see. What am I going to do here? All right. I'll go ahead and do this one. I think I'm just going to do one more example, and then I'll be done with this, okay? So here comes the second example. I have that y squared plus 10y, and let's make it plus 8. I'm making this as I go along. Okay, can't you tell? Okay, so anyways, guys, here it is. I'm going to move the 8 over, so this is going to become a -8, all right? Okay, this is not going to work out very well, but we'll go ahead and deal with it anyways. You know what? I feel like erasing this, so let me erase this a little bit, okay? I'm going to adjust this because I want this to come out nicely, okay? I'm going to make this a 6. That's it. That's all the changes I'm making, okay? Everything else should be good. So now, guys, listen, I moved the constant term over, so it's now a -8 on the right side. So now you want to take half of 6, that's the b term, that gives you 3. Then you square it, so that gives you 9. Add the 9 to those sides. So now, on the left side, we're going to factor this into 2 binomials. What 2 numbers multiply to give you 9 and add to give you 6? Wait a minute, that was the same problem we had with the previous one. Shazam. Okay, we'll work with it, guys, okay? -8 plus 9 is 1. So as you can tell, we have a repeated factor. By the way, there's a shortcut to get to this binomial square. So you could just take a y from the y squared, half of 6 gives you 3. Yeah, that's easy. So now you take the square root of both sides. Remember, plus or minus. Ooh, look at that, guys. Square root of 1 is 1. So now you have y plus 3 equals to plus or minus 1. So now we're going to go ahead and subtract the 3 from both sides, or just move it over. So if you take it, move it over. So this will become y equals to -3 plus or minus 1. You cannot leave it like that. You're going to get 2 exact values. So you're going to find the sum, -3 plus 1, which is -2. Then find the difference, -3 minus 1, which is -4. So there's your 2 exact values, just like that, guys. Yeah. It's okay if you didn't fully get that. I mean, you will see completing the square again in different scenarios throughout the class. So if you didn't get it now, you'll get it later, okay? So I'm gonna go ahead and move on to the quadratic formula, which is everybody's favorite. And then we'll go ahead and finish with solving the quadratics. So method number 4 is the quadratic formula. And everybody should be very comfortable with the quadratic formula. Now, you don't just go straight into the quadratic formula like that, guys. There are steps to the quadratic formula, okay? Remember, the quadratic equation is in the form of ax squared plus bx plus c is equal to 0. So the first step, guys, is to isolate the quadratic, as in get the quadratic by itself, set it equal to 0. Yeah, I know there are steps to this. Number 2, you're going to identify or list the values of A, B, and C. A, B, and C. A, B, and C, guys, okay? Now remember, A is the number in front of x squared, the leading coefficient. B is the coefficient of x, and C is the constant term. So guys, what happens though? Remember, A cannot equal to 0, because if A is equal to 0, you no longer have a quadratic equation. So what happens if you're missing a B value or a C value? You're gonna have to fill in 0. Here, let me write this down and put a star next to it. Fill in 0 if B or C is missing. Yeah, you need those placeholders, okay? So if you're missing the value of B or the value of C, then you fill in a 0. But guys, as always, remember, A cannot be 0. Why? You would no longer have a quadratic, okay? That's plain and simple. All right, so now step 3, we're going to substitute A, B, and C, the values of A, B, and C, into the quadratic formula. All right. So let me go ahead and write the quadratic formula for you guys. And no, yours truly will not be singing it. I am not that type of person who's going to be singing the quadratic formula to you, okay? So guys, here's the quadratic formula. Now, be careful. When I talk about the quadratic formula, I like to say x equals the opposite of b, because many students have a tendency to forget to change the sign of the b value. And they just say negative b. Well, what if b is already a negative? You're going to remember to change that negative b to a positive? Are you going to remember that? So to avoid that confusion, I like to say x equals the opposite of b. So if it's a negative, okay, it becomes a positive. And if it's a positive, it becomes a negative. So x equals the opposite of b plus or minus the square root of b squared minus 4 times the value of a times the value of c. And then all of this gets divided by 2 times the value of a. And there's your quadratic formula. Now, guys, it's a really good idea at this level, algebra 2, to memorize the formula if you haven't already done so, okay? Because you're going to use this over and over again. Now, step 4 is to go ahead and simplify. So once you plug in all those values, A, B, and C, into the formula, the last step is to go ahead and simplify. Now, one last thing I need to say about the quadratic formula, and then I'll do a couple of examples, and that is the discriminant. The discriminant, b squared minus 4ac, the part inside or under the square root, determines the number and types of roots. Remember, roots, zeros, solutions, x-intercepts, they all mean the same thing, okay? So the discriminant basically informs you of the number and types of roots to the quadratic. So how many solutions does it have? And what type of solutions does it have? Remember earlier I mentioned there are instances where you have no real roots. So if the roots are not real, then they become imaginary. So guys, here's the bottom line with the discriminant. So if you calculate the discriminant, it's greater than 0, meaning it's a positive value. This will lead to 2 real roots, as in they're going to intersect the x-axis twice, as mentioned earlier. Now, if you calculate the discriminant and it turns out to be exactly 0, this will lead to 1 real root, as in it's going to intersect the x-axis once if you were to graph the quadratic. By the way, we are going to be talking about graphing the quadratics too. So that's coming shortly. Okay, next. If you calculate the discriminant and the discriminant is less than 0 or it's a negative value, this means you have no real roots. And if you have no real roots, what do you have? Imaginary roots or complex roots. Ooh, I need to talk about imaginary numbers, guys. I haven't talked about imaginary numbers yet. Imaginary or complex roots. We got to talk about that. Imaginary numbers, okay? So guys, that's what happens with the discriminants. There are three possibilities for the discriminant. This is what drives these quadratic equations, the discriminant. If the discriminant is positive, 2 real roots. If it's 0, 1 real root. If it's a negative value, no real roots. Therefore, it would lead you to those imaginary solutions, all right? So I'm going to do just a couple of examples, and then I'll be done with solving these quadratics. Of course, you will get some word problems too. We'll cover those in class, okay? So guys, here's one for you. Let me see here. Let me find a really, really good one, because I don't want to give you one that's going to be too complicated. I want to give you an easy one. Okay, so let me find a good one. So I'll grab one of the ones that we had from earlier. X squared plus 11x is equal to, ooh, Shazam. No, I don't want to do that one. All right, let me erase this. Yeah. Let's try this one right here. X squared minus 2x equals to 15. That's easy, okay? So on this one right here, first step is to take that 15, move it over to the left so it becomes a negative 15, so we can isolate the quadratic. Now the quadratic has been isolated. It's been set equal to 0. You list the values of A, B, and C. The value of A is 1. The value of B, be careful, negative 2. The value of C is negative 15. Now we go into the quadratic formula. We're going to plug in these values. So listen, the opposite of B. B is a negative. So when you do its opposite, it's going to become a positive. It was a negative, so it becomes a positive. Plus or minus, the square root of B squared. Now, because the B value is a negative, I'm going to enclose it inside a set of parentheses because I need to square a negative. Minus 4 times the value of A, which is 1, times the value of C, which is negative 15. And all of this gets divided by 2 times the value of A. Now guys, be careful when you're typing this into your calculators. Negative 2 squared, that's positive 4. And let me write it over here, okay? And then negative 4 times 1 times negative 15, that's going to give you 60. You see that? So we add them together, we get 64. You can type all of that into your calculator right away. Negative 2 squared minus 4 times 1 times negative 15, it should give you 64. So we get 2 plus or minus the square root of 64 over 2. Now, take the square root of 64 since it's a perfect square, so that gives you 8. Now guys, what do you notice? We have a compound equation. So let's solve it out. We're going to end up with 2 answers, 2 solutions. So one of them will be the sum. 2 plus 8 divided by 2, which gives you 10 divided by 2, and 10 divided by 2 is 5. That's the sum. And then the difference, 2 minus 8 divided by 2, which is a negative 6 divided by 2, and negative 6 divided by 2 is negative 3. So guys, we're ending up with 2 exact solutions in the form of positive 3 or, positive 5 or negative 3. And just like that, we're done. Now, here comes the second example, guys. For this second example right here, I am going to do this one. It is number 2, x squared plus 3x is equal to 0. Now, we saw something similar to this earlier, okay? So, I don't know if you guys noticed anything, but I'm not going to tell you until the end. By the way, I forgot to mention that with the last problem too. Okay, I'll mention it after I'm done with this one. The A value is 1 because we have our x squared, the leading coefficient is 1. The B value is 3, but we're missing our constant term, so we fill in a 0 for it. So now we go back into the quadratic formula. We do the opposite of B, and B is 3, so it's going to become a negative 3. And this is going to be plus or minus the square root of b squared minus 4 times a times c. Now, guys, you see what's happening here? Because we're multiplying by 0, Shazam, all of this cancels out. So that leaves you with a negative 3 plus or minus the square root of 9 over 2. Square root of 9 is 3 over 2. And again, this represents two equations. So we're going to break it up into the sum, negative 3 plus 3 over 2, which is equal to 0. And then negative 3 minus 3, the difference, which gives you a negative 6 over 2. So you end up with a negative 3. So again, this one is producing two solutions, 0, negative 3. Now, guys, what I want you to realize is this, okay? I didn't say it with the last problem, but I'm saying it with this one. You see how you're getting these exact solutions? That's because this problem right here was factorable from the beginning. Did you guys notice that? Yeah, you could have factored this one. Shazam. Okay, this one has a GCF of x. If you were to factor it, you would get x plus 3 equals to 0. So one of the solutions obviously would be 0. And then what number plus 3 makes the parentheses equal to 0? Negative 3. Yeah, you could have done the same thing with the previous problem too. Okay, I don't know if you guys noticed that, okay? I think the previous problem was x squared plus 2x is equal to 15. So you could have set this equal to 0 by moving the 15 over, so you get a negative 15. And then factor this into two binomials as an x plus 5, x minus 3, and then solve it. What number plus 5 makes it 0? Negative 5. What number plus 3, minus 3 makes it 0? Positive 3. Yeah, you could have factored. So guys, when you get these equations, don't just jump in there and start doing the quadratic formula. Find the easiest method, find the most efficient method, and use that to solve the problem, please, okay? So I'm going to stop here, guys, with solving these quadratic equations. We'll do additional examples in class. So until next time, bye.